called Berkeley Labs, and they have something called Berkeley Time, and they never start a seminar before 10 minutes have gone by. Very kind of snooty. Okay, maybe I'll just start with the introduction, because if people miss the introduction, it's not that big of a deal. So welcome to the CMIP6, CMIP7 session. The idea of this session is to take stock of the use of scenarios in CMIP6, specifically scenario MIP, and then a few other MIPs that have used variants of the scenarios that were used by that MIP. And since for those of us that are related to Earth system model, we think with dread to the idea that we are already starting to think about CMIP7, but that's the reality. And so we want to have a conversation here with this community, trying to figure out what we should do better, differently this time around. In particular, how many scenarios are relevant and useful, what type of scenarios, both in terms of shapes of the trajectories or composition of the trajectories. And to do so, we have organized 3 short presentations. We have one online by the current chair of the CMIP panel, Jean-François Lamarck. He's going to give us an overview of what has been learned from CMIP6, and in particular from a survey that was made. And then we have Ben Sanderson and Matthew Giddens. They are going to give us some thoughts on some very different aspects of the whole enterprise. And then we will have a good chunk of time for discussion. And this is a session that has been organized by a lot of people, but at least 3 or 4 of them have fallen like flies, and only Detlef Van Buren and I are here. So we are the responsible in the rooms if you want to give us feedback even afterwards. Okay, thank you. So we have Jean-François now. Is he ready? That's not Jean-François.
Great. My understanding is that the video will be shown. Yep.
You can go ahead, Jean-François.
The organizers for giving me the opportunity to talk about the planning for the next phases of CMIP.
But Jean-François is online, ready to answer a question and participate in the discussion. You people on Zoom, please stop talking now. No, that's okay. So you guys heard what I said, though, so.
I'd like to thank the organizers for giving me the opportunity to talk about the planning for the next phases of CMIP. I am Jean-François Lamarck. I'm the current CMIP panel chair, and I'm giving this presentation on behalf of the whole CMIP panel. Just as an overall overview, the primary objective of CMIP, the coupled model intercomparison project, is to understand past, present, and future climate changes in a multi-model context. I think it's important to remember what CMIP is about, since not everything will require this approach to be successful. CMIP started in 1995, and one of the key factors in starting this was the definition of common experiments, in this case idealized, forcing with something that would be very clearly defined for every model to perform to really enable afterwards the intercomparison of the results. Over the last couple of decades, it's been really clear that CMIP plays a dual role. It is both a scientific enterprise, and it also clearly supports policymakers. And so, in that sense, CMIP has played a really critical role in supporting IPCC assessment reports, for example, or other assessments. And this is done through data and papers that are being written from the analysis of CMIP simulations. One could argue whether this number is reasonable since models are being developed regardless of CMIP, but the bottom line from this 2018 WCRP review is that CMIP6 is a very significant enterprise, and I think it is incumbent to us to really think about how to optimize these resources, whether they're in terms of supercomputing or personnel time that is devoted to the development of the models and the performance of the experiments. And of course, in the end, and this is extremely important as the data are being used for, in this case, the last 3 IPCC reports from Working Group 1, 2, and 3. And then compared to CMIP6, the overall picture that we have is quite disconcerting, with the recognition that we are getting really close to the 1.5 degree target here. The last estimate in this case from the Working Group 1 is that we're right around a degree and a quarter, already above pre-industrial. So we're getting really close, probably within a decade or so, of reaching out to the 1.5 degrees Paris Agreement target, or probably not too long after, if we continue at this rate, the 2 degree target. And so I think it is really important to start thinking within the constraints of the world as it is going, and the direction that it is taking. What is the most relevant and important science that we need to do to address the targets, the 1.5, 2 degrees target that we feel are necessary to limit. And in that sense, scenario MIP was really playing a key role by pushing not just for the definition of climate forcings, but the underlying socioeconomic pathways. And so it was really important for scenario MIP to do that for CMIP6. But then what is it now? That scenario MIP and the overall discussion of what CMIP7 should be, where should we go from now? To do this, we have performed a survey that we're in the process of analyzing. You have here the fraction of respondents, and we can see that about 25% of the respondents are outside of the European and US zone. It's not very large, but at least we're capturing some of the other players in this arena. One thing that I was really pleased with is that most of the people who responded were out with analysis. So this is not something that the responses are not completely driven by the different groups, but they're very specific to what analysts are interested in seeing. From this, we can also see that scenario MIP was by far the most interesting MIP of all. Others were quite interesting based on the survey and the analysis of mostly individuals. And that scenario was central to the analysis that they wanted to perform. Overall, it is clear that whether it's the scientific focus or the way MIPs were designed to address the scientific priorities and goals, that the overall approach that was designed in CMIP6 was successful in that aspect, with the vast majority of satisfied or very satisfied respondents. So the goal here is not to drastically change the overall way of doing it, but then we can start looking at what is the most relevant, what is the science that we need to do, and how we're going to do it. As I mentioned earlier, the targets of reaching 1.5 or above are really at the center of some of the mitigation goals that are being defined at the country level. But I think it's also incumbent for this community to realize that we are playing a significant role in the generation of carbon footprint. And we should start thinking about how we as a community can contribute to reduce this. And so I think we should have, as part of the overall design here, another constraint, not just the 1.5 and the external world, but also what we as a community want to do in reducing our carbon footprint. So this slide is actually encompassing a lot of what the thinking is in the defining and the planning of the CMIP7 and other phases. We really want to help people understand their carbon footprint and maybe can start looking at using green energy supplies, but those are things that are really not under the control of what CMIP can do. But so I think what we should instead be looking at is how much of CMIP6 can we reuse? I think we have to define what are the science questions that we want, and can we actually answer some of that? We have generated 11 petabytes of data. We have had simulations performed by 45 modeling centers and 100 and some models. What can we do? Continue to dig into this resource and answer the questions. And then along the same lines, what are the myths? What are the answers? What are the drivers here? What are the questions that we want to answer? Not everything has to be done under the CMIP umbrella. So let's think about optimizing and really maximizing the output compared to the input and the amount of people and computing time that we're putting. For example, how many ensembles do we need? How many simulations at high resolutions do we need? Do we need all modeling groups to do everything with their state-of-the-art model? And there's a huge effort in this scenario workshop about emulators and what they can do, what they cannot do. And it's really thinking broadly about what is the optimal set of information that we can generate and how we're going to optimize the resources that we have. So this is really going to be one of the driving principles in defining what CMIP7 is. I know it's a tall order, but I think it's really critical for us to define what we can do with what we have to be achieving all the objectives that CMIP has. It's societal relevance, science relevance, carbon footprint, and accessibility. Accessibility of data and its usability by the worldwide community that wants to look at the impact in the region where they live is also going to be a significant driver in the way we move into CMIP7. So this is still very much a plan, and there is going to be a lot of input from this community and the broader modeling community and user community to really define explicitly what CMIP7 will look like. And with this, I thank you, and I welcome any question.
Let me see if there are some pressing questions for JF. Otherwise, I would suggest we go to the other presentation and then we discuss things as a whole. But if somebody has clarifications or just immediate reactions, please raise your hands. Oh, I have intimidated you into not doing that. Okay, so did we decide the order here? Does it matter? Okay, I decided Ben come up, and then also because I have this.
Oh right, okay. Well, that's a good idea. Right, hello. So I'm going to take, I guess, a more removed perspective from the considerations for CMIP7, and specifically about the challenges from the policy space, from society, in terms of what are the evolving demands on CMIP, and how we might need to think about going forward and building on and modifying this experimental design. And since the inception of CMIP6, the major thing which has changed is the Paris Agreement, as everyone in this room knows. But the Paris Agreement, to some degree, has changed the central question which we ask of Earth system models. If over the first few iterations of CMIP, they were really used to address the former question here of how the Earth system would respond to continuing emissions. And then very rapidly, within a very short period of time, we're using these models to address a related but not identical question of what does a net zero world look like. And this question, and modifying our simulation capacity to address this question, requires considering both what our models look like structurally, but also what kind of experiments we do with them. And so there's a subset of things that we want to know from Earth system models which still remain core, like the fundamental parameters like climate sensitivity, transient response to cumulative emissions, and understanding the breakdown of how physical processes contribute towards our projection of uncertainty in future climate change. But then there's an extra layer of things which we are now really critical and central to our ability to have confidence in where we're going in terms of climate. Our primary uncertainties now are not merely climate or carbon uncertainties. They are a combination of the two. As we move towards CMIP7, we need to be thinking about ways of quantifying our understanding in a reliable and reproducible way across the models to understand how these joint carbon-climate processes evolve over different timescales. And we also need to think about how to go about more robustly simulating the kinds of scenarios which we weren't even thinking about at the inception of CMIP6. So when we were putting together the original scenario MIP design, there was no scenario for 1.5 degrees, and that was added further down. And so as we go into this in a more mature state in CMIP7, we need to think about what the fundamental uncertainties are from the Earth system modeling side, which contribute to our uncertainties in being able to simulate high mitigation scenarios. And we need to think about where humans fit into this picture. And there's been some good talks about that in the previous sessions. But where does it make sense to incorporate human processes into Earth system models, and to what degree should we be taking on these challenges in the context of CMIP and scenario MIP? And so the primary thing which we face, and the primary difference from the kind of scenarios which we were thinking about in CMIP6, is that our primary uncertainty, perhaps, when we're thinking about 1.5 and 2 degree compatible futures, is no longer transient climate response or climate sensitivity. It's how much carbon we can pull out of the atmosphere by modifications to the land surface. And in order to answer that problem completely, we need to improve the process representation of carbon and land use processes within the Earth system models, but also on how they interact with the fundamental carbon cycle uncertainty in those models. And if you think about the way that our current scenario design works, our current transmission of information from scenario design through system modeling through to impact modeling, it doesn't allow for this, because we really consider three sets of conditional probabilities. We have a set of models and infrastructure which gives us emissions conditional on levels of policy ambition. Then we have a second set of models which gives us climate conditional on those emissions, and a third set of models which gives us impacts conditional on climate. And there are exceptions to this, of course, but this is broadly how our field is structured. But in order to address these questions, these fundamental questions around the scenarios which are dominant in the policy space and where all of the political interest lies, we need to draw all of these lines which go backwards up the chain. And so what does that look like? What does that look like in the context of CMIP, and what does that look like in the context of what we shoulder in CMIP7? And one obvious candidate for that is to start thinking about now maybe is the time to shift away from a scenario MIP which is based on concentration-driven scenarios. What capacity do we need at this? And we need to be thinking about this at this point in the development chain. To what do we need from the Earth system models to be able to increase the fraction of scenarios which we can do in an emissions-driven framework, and critically a land-use-driven framework. And so we need to, these arguably, the land surface models within the Earth system models are the most complex representations of the land surface we have. And we're not using that information at the moment. So, or at least we're not using it fully. So how do we go about actually implementing processes like BECS in the Earth system models, and is in a way that is convincing across the board to inform what's ultimately being assumed in the IAMs? To move on to a different topic, CMIP6 has highlighted an issue of model democracy, which has underpinned the way that multi-model ensembles have been used for the history of the IPCC assessment process. Up until now, we have considered at least approximately that the CMIP ensemble is a proxy for uncertainty in climate response. And it's been jarring in CMIP6 that because of the differences between the assessed range of climate sensitivity and the distribution of climate sensitivity which we had from CMIP6, that this assumption of model democracy was not allowed, was not used throughout the assessment process. And so in place of that, we've seen a rapid acceleration in the use of emulators as a translating tool in between Earth system modeling simulations and assessment. And this has been a very successful endeavour. There's obviously a massive turnaround, flexibility associated with the use of simple climate models, but equally we should be cautious in that we are down by some means. CMIP and the models contained within it contain the most sophisticated, complex representations of the Earth system we have, and we are, because of this relatively simple issue that the distributions of two Earth system parameters don't match, we're throwing away quite a lot of the information that we have embodied within the CMIP process. So we, as the Earth system modelling community, now need to think about how we can address this issue moving forward. We've arguably been lucky, perhaps, over past cycles in that the distribution of projections which we've had from CMIP has broadly been consistent with our assessed ranges of the uncertainty from other sources of information. But this is perhaps more coincidence, and this is perhaps more luck than we might like. And so we need to think about about the calibration process, about the model selection process, and how then they get represented in the distribution of the final ensemble that we have. And still core to this is the idea of emulators. They're not going to go away, but the way that they were implemented in CMIP6 is more of an afterthought. We had the simulations which we had from the deck. And they're useful, but they're also not. In many ways, they're not ideal for calibrating the emulators to be the best possible approximations of the Earth system models. And one of the core aspects of this is the length of time we run these idealized simulations for. If you run an idealized simulation for 150 years, we're left with large uncertainties in the fundamental parameters of the simple climate models and how they respond on different timescales. And for questions, really policy-relevant questions like constraining ZEC, this is a first-order problem. If you take the output from ZECMIP, for example, you can fit a wide range of simple climate models with a huge range of ZEC. And this could be fixed by having longer simulations and more carbon climate relevant simulations which are performed by default in the Earth system models. And so we face this challenge in CMIP7 of competing philosophies for how computational resources should be used, with models spanning from simple climate models like FAIR through EMIX, through Earth system models of CMIP6 class, through to kilometre scale resolving models. And there's a valid question in the community of where our efforts should be focused in terms of development moving forwards. I think the answer to this is that there's value and there's assets in all of these models, but the challenge, as Jean-François suggested, is being strategic and being optimal about our models of different classes, and when we're really learning something and when we're not. So, for example, if by running very large initial condition ensembles, how much of that, how big do you need to go before you can statistically infill the initial condition ensemble? How much more are you learning, and would that computational time be better spent on making longer simulations, for example? Also, objective calibration. CMIP6 has highlighted this issue of climate sensitivity, which has got a lot of press, and has been the first order argument used for down-weighting the role of the ensemble in the assessment process. And so we need to at least think about the question of calibration of fundamental Earth system processes and parameters within the ensemble. And this doesn't mean tuning our climate sensitivity, but it does mean understanding how our model parametric and design choices project onto climate sensitivity. And if we can produce models which have a range of climate sensitivity with similarly performing climates, then we should be submitting those runs to CMIP, because that's an invaluable part of addressing this gap between what we're getting from ostensibly an ensemble of opportunity and making an objective statement about climate uncertainty. Yeah. And finally, we need to run simulations for longer. It's been clear from those few simulations which used the scenario extensions up till 2300, there's a huge amount we don't understand about the carbon cycle response on the post-2100 timescale. And as a scenario community, we need to then put more weight on post-2100 development, maybe even detlef from the integrated assessment models, but also from a physical system process on a much longer timescale. So, thanks.
Oh, you have questions now. Yes. No, please.
I'll come back to it.
Yeah, we will have time. So Matthew, would you like to? We need to wait for the presentation, but try it again. Yeah, it works. We need an extra.
Should I change it here or okay?
Don't touch it.
Yeah.
We don't know. Oh, we can do it ourselves.
Yeah.
Thank you.
But it's nobody told you, so it's okay.
Okay. Thank you.
Okay. And now for something a little different, indeed. So while the slides come up, maybe just to contextualize a little bit. So Ben, I think, gave a really great overview from the climate modeling perspective. What I'm going to hope to do is bring us back a little bit to history to understand from the scenario MIP perspective what were the steps that we took, what were some of the decisions that we made, why did we make them, and what did we make or what were good decisions and what are things that we could probably improve upon. I should note at the outset here that the scenario MIP effort was a wide effort across 5 different modeling teams, 3 from Europe, 1 from the US, and 1 from Japan. And these are just some reflections from a small group of those, and so don't necessarily reflect everyone. I think it's useful just to take a step back and think about what the timeline was that we were working with under CMIP6. So we use the SSPs in CMIP6, and in fact the SSP-RCP matrix. Those were first conceptualized by a paper by Brian O'Neill in 2014, quantified in Riahi et al. In 2017, and then we're starting to be proposed for scenario MIP in 2016, where Brian had his scenario description paper. We finally started producing the data in academic published papers in 2019, where we provided harmonized and downscaled emission data, 2020 gridded data, and then the MAGIC team provided concentration data in 2020. It's worth noting that obviously we're just talking about the anthropogenic emission and concentrations. There was a parallel effort to provide land use patterns, first described in 2016, and then in George Hurt's paper in 2020, the data was provided. And then finally, Claudia's paper summarized many of the key results for the ESMs in 2021. So we're really talking about conceptualizing the scenarios on the order of 6 to 7 years before finally getting the ESM outputs, and on the order of 5 years before actually generating the results. So there's quite a long time frame here. This is the SSP-RCP matrix, which I think we all know and love so well. So this is just to refresh us. Again, we heard this in the opening plenary. There were 4 Tier 1 scenarios. Those are the ones that are focused on by the ESM community. So every ESM group that can do a scenario focuses on the Tier 1 scenarios. Ben made a really important point in his presentation that this framework and architecture was done basically in parallel time-wise as the Paris Agreement. And so a 1.5 degree scenario came in as a Tier 2 scenario, which means that not all of the ESMs were running them. And actually, as Valerie reminded us in the opening discussion, we had a single overshoot scenario on one of our highest emission scenarios in SSP, or a higher emission scenario in SSP5. And then finally, there was a single scenario also looking specifically at non-CO2 forcing and specifically short-lived climate forces, and that was also a Tier 2 scenario. So I want to walk you through, for those of you who are not aware of the process that we went through in looking at scenarios and processing them so that they would be ready for Earth system models. This is an overview diagram, and I'm just going to walk through it very briefly. So first of all, there was a compiled historical data set on the right-hand side. So this is from Hosley et al. For anthropogenic emissions, and Van Marl et al. from burning emissions for land use. This is compiled into the SEEDS data set. And then we also took scenarios from the integrated assessment model and scenario community on the left-hand side. Those scenarios, because again they were developed over a long period of time, are calibrated to different historical emission data sets, for example, and don't necessarily match in whichever year CMIP6 decided to use for the starting year from historical simulations to future. So we had to first go through a process called harmonization. This was actually a very rigorous process, so each modeling team individually for each region and sector looked into what is the right harmonization approach to take. We provided some tools. I'll get into that in a moment. After doing the harmonization process, we started looking at climate forcings, making sure that we aligned with the original intent of the scenarios we provided, while simultaneously downscaling them to a country level. And this was a pre-processing step before then gridding those emissions, which would be effectively the final data product coming out of our work within scenario MIP. And the other important thing we saw in JF's presentation, scenario MIP contributed a lot to other MIPs, and this is just a small sample of them, or maybe not so small sample, as much as we knew at the time. There was a handover after producing the emissions trajectories to the MAGIC team, and their job was to produce trajectories for concentrations. It should be noted that these concentrations were produced directly from the scenarios themselves, but then also extended until 2300. And that extension logic was first described in our scenario design paper. Now, because of the long chain of events to generate the data, the scenarios were only extended in after we were able to deliver them to the team, and that was done in 2020. So there's a 4-year gap between the design of the scenario extensions and the actual data provision, which then can lead to some inconsistencies between what was originally thought of and what was delivered in the end. And the final thing I wanted to say, because I'm trying to tell you about what are all the data sets that we're producing for ESMs, that's not all. So there's also data sets for solar irradiance and also data sets for ozone for ESMs that need additional fields for if they're lacking a chemistry module. So that was actually a lot of work, as you might imagine, and we could not do that all by hand, obviously. So a big focus of our work within Scenario MIP and CMIP6 was to automate as much as possible. And so this is a set, perhaps not full set, but a set of tools that were generated during the process. So first of all, we had a harmonization tool, which was able to let us do this harmonization part automatically as much as possible, so that then the scenario teams could focus on vetting those harmonization methods. We did this for 14 different sectors of the energy system and economy and 13 different emission species. These were then downscaled individually based on different patterns of production and activity. That was a separate library. Our colleagues at the MAGIC team and other simple climate modelers also did a lot of work to make sure that they could take any IAM output and any SCM that produced or that formatted their input to a standard interface could then run those scenarios. And I think it's really important to point out that there are co-benefits to other parts of our community, because a large part of these tools we developed in this project then went on to assist the IPCC climate assessment. And there's a paper that was just submitted in GMD describing that. So I want to finish on a couple of different kinds of recommendations. And so I've split these into different categories. And these are just reflections from us as a team in terms of what we think we did pretty well and what we think we could do better. So first, I want to focus on some of the technical issues. So we spent a lot of time dealing with historical data sets. And this is something that sort of we tried to look at, like, what were all of the data sets out there, what were the best ones to use, how do we make sure that we're aligned as strongly as possible with the historical data sets used for the historical ESM runs, et cetera. We at one point had to make a hard decision because we got a brand new data set for sulfur coming out of China, which really revised sulfur emissions downward, had to struggle with that question. And so I think across the full historical data set chain, it would be great to have a mechanism to make sure that we have consistent historical data across all MIPs. And a lot of work was done in our CMIP to push that effort forward. The second thing that I would note is that we had a very unspecific or a low resolution for land use emissions for scenario MIP. We harmonized to a single global trajectory. We know that land use emissions are incredibly important also for detailing the ESM outputs. And this also was not necessarily in line with parallel efforts by LUMIP. And so I think having a better representation of CO2 flux fields, also making them consistent with the land use models is pretty important. And then I think we can actually do a better job improving some of the methods that we already developed. Happy to talk about those later. But I think a critical aspect is to try to come up with a fast-track process so that we can partner with 1 or 2 ESMs who are ready to try to start using our outputs and start this process early in the chain so we can actually work through that handshake earlier on, rather than just sort of throwing data over the ESGF fence, basically. And then there are a couple of recommendations on process. So I wanted to re-highlight that this was a really strong collaborative effort within the IAM community, which I think was really valuable and something that we should continue going forward. But we also experienced a pretty serious lag time between sort of us getting started, handing over to the next data sets, handing over to the next. And so I think it's really useful to try to come up with a process within CMIP6 to help identify potential lag issues and to try to reduce that lag time. I've made some suggestions here about different better efforts of collaboration. So what I've described here I would call the data value chain, so moving from the input assumptions for the SSPs all the way down to the data for the ESMs. I think we need stronger collaboration there. And I think part of what we can do in order to achieve that is to have a specific sort of coordination group with representation from each one of these communities that talks on some frequent level about progress towards progress that we're making towards that. I finally want to finish on some scenario-based recommendations, and Ben sort of laid the groundwork here a little bit in his previous scenario, his previous talk. The first is that we really, in my opinion, need to focus on policy-relevant Tier 1 scenarios. So we need to make sure that we have, within the Tier 1 scenario set, what we think as a community not only are relevant scientifically, but also are relevant from a policymaker perspective. Among those very policy-relevant issues, I would say on the one hand are trying to get our head around what are the critical questions around overshoot. Ben also mentioned this as well. And then also exploring key uncertainties around scenario uncertainty, climate uncertainty, and carbon cycle uncertainty about how we actually are removing carbon from the atmosphere. And so maybe thinking about a land use-based CDR scenario versus a technical-based CDR scenario, and understanding what are the differences there. Recognizing that I'm over time, I'm just going to summarize big picture main recommendations. So what I ended on there, so policy-relevant low-end scenarios for Tier 1. I think we need to continue automating the full data value chain as much as possible, specifically so that when new policy-relevant issues come up, we can actually, in an agile way, add them as Tier 2, so they're not sort of done. Let's put it this way: we can maximize ESM participation in policy-relevant Tier 2 scenarios. A third example or a third suggestion is to enshrine the historical data process as a first-class activity, and to make sure that's given prominence so that all the entirety of all MIPS understands sort of what are the right data sets to be using there. And then finally, to develop this coordination board or coordination group with a specific mandate to help develop these turnkey approaches across the full data value chain. And so with that, I'll stop there. And I don't know if we want. Oh, yeah.
About the fact that we had some interesting posters submitted to this session that you can find online. One of them was shown yesterday by Goran, who is still here, so you can talk to him. They were about adaptive scenarios, probabilistic scenarios, volcano forcings in scenarios, and probably I'm forgetting another one. But please, if you are interested, check them online, and I thank the submitters for their work. So I guess we can open for discussion, bright ideas that will facilitate the design of the next experiment. Oh, okay. Sure. What do I do? I can. Okay. And who is it? Bjorn. Bjorn, I think you can talk. You're gonna be put on the screen in a moment. Just a sec. Oh yeah, you're here.
Okay, thanks.
Go ahead.
Thanks to all the speakers. Really interesting presentations all the way. I just have a question for clarification before we get deep into the scenario design process. I mean, this is a scenario discussion, of course, but the scenario development process around that cannot be independent of the model development that will go on at the same time. So I was wondering for CMIP, maybe this is for JF or someone else. I mean, how is the timeline for ESM development? Do we know what the major ESMs will include, and should that be a consideration for what questions are put in the scenarios? And also that needs to be seen also in relation to the massive development that's going on in the emulator world, of course.
So I guess you'll have to put JF. You're going to be put on the screen in a moment. Jean-François.
Yep. Can I start answering?
No, I'm not talking to you. Okay, great. You're here. You can respond. Yeah.
Can you hear me?
Yep.
Okay. So, Bjorn, that's a great point. And one thing that I didn't mention in my presentation, and very much related to the kind of things that Matthew was discussing, I think there's a strong need for interactions between, in this case, scenario map or the generation of scenarios, whether on the technical aspect, but also on the scientific aspect of what can or cannot be done, and the modeling community. So as part of the CMIP7 definition process, we will start putting teams together. Don't know yet if we're going to call them working groups or task teams. But the idea is to integrate those discussions in the design instead of as an after the fact or left up to in this case scenario map for the previous time. Instead of leaving it up to that group, we will tackle that within the definition of CMIP. So we're just about to send out the call for some of those task teams, and we're hoping to get a fair amount of people who are deep in those problems to contribute to the definition of what it's going to be. So we're going to try to have a much more integrated approach to CMIP and to hopefully address some of those questions. But I don't have a specific answer. I can tell you about CESM, but maybe 45 other models. So I don't have an answer directly to your question, but only that we will hopefully have the process in place to make that happen.
Okay. I guess we can start with the audience now. Yeah, so I guess you that didn't get a chance earlier, right? Can we have the microphone, please? Yeah. Maybe.
All right, thank you. I was interested in something Jean-Francois said about optimization, essentially, and talking about the fact that CMIP6 had something like $3 billion spent on it. I quickly Googled CERN's annual budget's about $1 billion a year. So that's, probably double what CMIP6 is over the life of CMIP6, and NASA's annual budget's about $22 billion a year. So my question is, do we lack ambition as a community? Like, should we be talking about getting more funding rather than trying to optimize and cut as much as possible?
Yes. So yes, have you tried raising several $1 billion more? Yes?
I think there are plenty of attempts at raising the profile of climate research at this point through some very, very large proposals. They tend to focus on creating a single or a very small, a CERN-like approach to the system, and I'm not sure that that is the best way to answer the climate question. I think, as Ben was showing, we do have to rely on a full ecosystem of modeling activities in particular. I mean, observation should be a big part of this. But if we focus on the modeling side, there is a huge, very large universe, and I don't think we can put all our eggs in one basket like the CERN to be answering the climate question. Whether we can justify that if we had another billion, and by the way, that $3 billion, as I mentioned, we can argue whether that's a realistic number or not, right? But would $1 billion more really? How would we use it to make a difference? Right, and I'm not sure that without optimization and whether we optimize $3 billion or $4 billion. I'm still not clear that it's a question of ambition versus a question of optimization and really targeting what are the questions that we want to answer and what is the best way to answer those questions. I think CMIP6 has shown the capacity of a very organic approach to it. And I think it has gone very, very far, but it might not be the best way and the only way to answer that. So, I mean, if you know someone with an extra $1 billion, I'd be happy to try to use it. But I'm not sure that money is the only way we can make significant.
I suggest we work with what we have and we start talking about scenarios and what we want to do next. So I had several other hands up. Okay, Chris.
Okay, I'll just shout.
No, it's not. Oh, there we go. Perfect. Okay. So actually, slightly, probably the opposite question to Zeb, actually. Mainly for Ben, but probably also relevant to JF. So Ben, you were kind of saying that we need models. We need models that can capture sort of all aspects of the processes that we're interested in. To sort of be more efficient, should we be sort of not considering models that don't have the capability, for example, for the carbon cycle or other aspects of the Earth system that we know are important?
I think that would probably be overdoing it. I mean, there's the value in CMIP is the diversity. So compared to, say, a simple climate modeling construct where you can conveniently represent your sort of probability space of your input assumptions and then produce estimates of future climate. Like the reason we do CMIP is because we want to have a diversity of responses. And if we said that we have no interest in models without an interactive carbon cycle, then we'd be losing some diversity on our understanding of climate sensitivity diversity. So I probably wouldn't go that far. But I do agree that there would be an advantage in really identifying as a community what are the key questions we're trying to answer, and then focusing our modelling effort on those questions in the most efficient way possible. And to reiterate what Jean-François said, this isn't necessarily a question of saving money or saving computer time. It's about identifying what is it that we learn from this class of model. Yeah.
Thanks. And just to announce, we have half an hour left, and I assume that some of you also want to express opinion at some point. And so let's continue with, first of all, the questions to the speakers, and then at some point let's open it up for a bit more discussion as well. But continue with the questions. So there's one at the end.
Well, I'm Shinichiro Fujimori from Kyoto University. Well, it might not be a question, but I would like to raise two things from my personal IAM perspective. And one is related to carbon neutrality things, and it might have already been discussed earlier, but I think recently we, at least in our integrated assessment modeling, we have three options to make a negative emission CDLs, and so one is afforestation, the other is another is BEX, and the other is DAX, and I think they have quite different impacts on Earth system. If we fully rely on afforestation, the quite large area needs to be converted into a forest, which may be quite different consequence in carbon cycles, and that's purely different from that aspect. And so, if if you are going to consider, zero emissions in terms of CO2, then I may want to include such kind of variations in the scenarios. I'm not going to say, it must be, but it would be highly policy relevant questions for the Earth system models. That's my personal perception. And the other one is related to aerosol emissions. And so if the carbon emissions are reduced as the current policy frames, maybe CO2 loss would be relatively low, and aerosol role may be much more important in the futures. And for the CMIP6 process, as far as I understand, the SSP3 RCP7 combination was the only one which were specifically focusing on aerosol reactions. Therefore, that could be also, I think, important things that should be having some variations. And I think in this CMIP6, there are several models that generate the high climate sensitivity, which my understanding is that it's related to representation of the cloud formation, which could also be related to aerosol emissions. And so I wonder whether it would be relevant for the next CMIP exercises. And related to aerosol, one more thing. It's also related to math presentation, but land use emission associated with aerosol emission associated with land use is also quite uncertain, not only CO2, but aerosol fire-related things. And at this moment, it might be very difficult to identify which fire is coming from anthropogenic, which one is coming from natural system. And ESMs or related fire-related exercises are now, I think they are not differentiating, but at the IEM side, we are producing some sort of anthropogenic emissions due to land use. And so maybe in our IEM side, we also have an issue to identify and classify the fire-related emissions. But at CMIP side, it may be also some more improvement rooms. So I just want to raise up that part.
Okay, let's try to, for now, do the questions and then do the discussion a bit. Would you want to? Yep. I think you're spot on all fronts. On the representing of different forms of CDR within the ESMs, I agree that's a core requirement. And when you think about like what would be practical on the development timescale of CMIP7 in terms of like actually enabling useful feedback on like differentiating the model response between afforestation and BECS and back. On the aerosol emissions, totally agreed. And so there's the uncertainty. I think we need to partition this into our uncertainty in historical emissions. Which at the moment is sidelined, and we decide on a most likely historical aerosol emission trajectory, and then that is common amongst all of the models, and understanding how uncertain that is, and how that relates to our uncertainties and climate feedbacks is first order. So if we can go beyond the point where we simply have a single realization of historical emissions, especially aerosol emissions, that could help enormously. And yes, on future emissions, agreed. Not just global aerosol emissions, but differentiating between regional clean air policies in different regions, and how that projects onto regional climate change. How many of these issues we can take on board for CMIP7, but I don't know. But that's a discussion we should definitely have.
Next question. Okay, I guess I have the next question. So I want to come back to something that was hinted at in the presentations, and this is, do we have to do everything new? And this comes to the Tier 2 experiments. I think there's a lot of good Tier 2 experiments out there, that have never been run, or only one or two modeling groups have run them. And I just wonder, do we need to give modeling groups a nudge to run some of these? I'm one of the co-leaders of CDR-MIP, and I know we had to be very selective in what was a Tier 1 and a Tier 2 experiment, and we left out some good ones and made them Tier 2 just because we knew modeling groups wouldn't participate because they were so overloaded at the time. So we said, well, maybe some good ones, like we have the SSP5 3.4 overshoot scenario in emission-driven mode. That's a Tier 2 experiment, and I've heard calls, it would be great if this had been run. Well, I think so far not many groups have run this, so we haven't done a multi-model comparison. I wonder, is there some way to give a nudge? I mean, this is still within CMIP6, or does it get carried over to CMIP7? But I think it's worth thinking about what's still valuable to do in Tier 2 experiments, and how do you get modeling groups to actually do these?
Jean-François, would you like to say something on this? Maybe not. Jean-François, are you still there? Okay. Is this a response, Yuri? It's the next question. Yeah. So I think by itself, okay. Did you hear the question, Jean-François?
I think. Can you hear me now?
Yeah.
Okay. So I could not agree more. I think this is exactly the point I was trying to make on how much of the new stuff should we try to make, or even more so, why would we want to wait for the next generation of our system models, which are going to take a few years to get there? Why do we need to wait to try to get more science? I think the question is whether the modeling groups might have the bandwidth to do that. But I think that is something that we have not received as a CMIP panel, was a request from the different MIPs to maybe ask the modeling centers as kind of an official request from CMIP to consider doing specific additional simulations. We get a lot of requests for more MIPs, but we don't get requests from that. So this might be, and I'm sorry, I couldn't tell who was asking the question. But please get in touch with us, and I'm more than happy to try to nudge the modeling groups into doing those simulations if there is a very strong case to try to get them.
Yeah, so maybe Jean-François, it would be good to announce that to the leads of the different CMIP groups as an opportunity.
Yep. I'm probably opening a can of worms right now, but
very quick.
I still think that is a very good way of building on the investment, the huge investment that was made for CMIP6. This is a small increment, and if it really changes the science that can be done for some of those MIPs, then we should really look into it.
Yeah, and maybe just very quickly, because you brought up the point of can we reuse from CMIP6, and I would go back to the question, is this the most policy relevant overshoot scenario that we're interested in? My answer would be probably not, given the present sort of circumstances, but that's something I think we should think about as a group.
Okay.
And that was my point about having a justification for making this request.
Thanks. That's really interesting. I just had a question more about kind of protocols in the next CMIP and sort of how to navigate them. So, for example, in scenario MIP, I think for the Tier 1 scenarios, each kind of scenario had a different marker integration assessment model, and so the emissions that were the kind of official or ones that were used predominantly for each scenario were from a different IAM. And that meant, for example, which obviously is to explore the uncertainty within the structural uncertainty within the IAMs, which is very understandable. But it meant that if you looked at particularly regional emissions differences, a difference between two scenarios you couldn't disentangle the difference because of the narrative versus the difference in the implementation of the narrative within the IAMs. And obviously, one answer to this is that you can kind of go back and look at the IAM, each IAM's version of you go across the same IAM, look at the scenarios. But in reality, when you have these emissions, particularly looking at the climate response that's been done, that all gets mixed together. And so I have a question of, how do we kind of tackle that? Is that just an intractable limitation of combining the uncertainty in IAMs versus the narratives? And how do we sort of make sure that this doesn't get tied in? And just being aware that when we make these choices to narrow down the scenarios, we can tie in some of these things in a way that maybe isn't optimal, and maybe there's a balance between that. Thank you.
So maybe as part of scenario MIP, I can try to answer that. And so it's obviously a design choice. We could have done this differently, but we chose the IAM that we felt was best representing that particular storyline. So that was by selecting different IAMs, we felt that we were better representing the storylines, and at the same time we felt that it was actually an advantage to also have another form of uncertainty being covered. Obviously, if we're going to have a limited set of scenarios within scenario MIP and within CMIP7, we have to see how we best answer specific scientific and policy questions. And it might be, and I think it's open for discussion again, whether you want to align, for instance, the IAMs and just have one IAM, or choose the same thing as we chose last time and choose from multiple IAMs. I see a huge advantage of the latter, but I can see also the argument that you were making. Yep. Although there are still many questions, and so if it's important.
Yeah, I have a slightly related question maybe, and so we already heard a few kind of calls for certain dimensions to be covered by scenarios, be it aerosols, land use, and so on. So my question to you is, how do we distinguish those policy relevant questions that can easily be tackled through a stylized experiment compared to a question that actually needs a, let's say, fully coupled IAM run and does a scenario MIP run? You want to start, or?
So there's obviously there's some experiments which are there are some questions which are best addressed using idealized modeling frameworks that like C4MIP or ICAM-MIP. But there's some questions where an integrated scenario design I think could be useful, and it's a bit conditional on, and it's related to the previous question as well, of if we should only be doing things with this class of models if the answer is interesting, and arguably going across the different IAMs as scenario sources for a given scenario was not an interesting thing to do in the experimental design of scenario MIP and CMIP6. But it would be if we had an emissions and land use driven construct in CMIP7, if different IAMs had different preferences towards different types of CDR, and they had different climate implications, that becomes a genuinely interesting experiment to do in a fully coupled framework, and it captures a level of detail which you don't get from the emulators, and feedbacks which you don't get from the emulators. So I think what we need to do is work out where it's worth running these simulations, and where we're gaining additional information that we don't get from emulators and pattern scaling. Yeah, I mean, what has come out of the last few years is that we obviously have that there's emulation and pattern scaling renders some of our current CMIP simulated scenario space redundant. We can more or less say, if we have RCP6 and we have the RCP 4.5, then we can say a lot about emission scenarios which just grow over time. But in these more as the policy discussion veers towards the net zero discussion, But then there are elements of this which are not going to come out of pattern scaling, and they're all about the intricate playoff between thermal and carbon processes and land use, and that's where these models have the most value in my view.
There's a question over here.
So I'm generally really excited to hear about the plans of increasing the number of scenarios which are consistent from a policy perspective to understand the policy dimension on the low end, and there are of course the scenarios that achieve net zero GHGs and have a large amount of CDR in there, and let's say land-based CDR, and looking into different types is obviously interesting. I was wondering to which extent the Earth system models and the land components cover some of the plant health issues, and also if you think about the current climate change that we observe in some parts of Europe, for example, we have extreme problems with keeping the forest stock, and management, for example, is an important component of that to retain the sink, particularly in Austria, for example. To which extent do the Earth system models represent those issues where we can answer basically the size of the sink and the sustainability of the sink that we see, so that we don't model only natural systems, but also the management that would help to retain that sink for the long term.
And that's a response to Kayman's question? Who is it? Yeah, then I think it's a new question. Somebody wants to respond to Kayman's question?
I think the answer is that's a very model-specific question. There's a huge diversity of the degree to which system models are representing both the complexity of land use changes and how they interact with forest dynamics and things like that, and the degree to which they're representing direct human impacts. Like some models are doing, some models doing a lot, some models still have rather simplistic assumptions on how land use change is manifested in terms of carbon sinks. And so, I think that's a question which goes down to the specific modeling groups, and like the scenario CMIP level experimental design has to just accept the models are in different places on that.
Great. Yeah. Brian?
Thanks. Hopefully you can hear me okay?
Perfectly.
Okay, great. So I wanted to make three hopefully reasonably brief comments. Two of them are brief anyway. So one is I just want to make a pitch or a reminder that I do think we still need high or medium scenarios. I understand the new questions. I think there's a great case for that on the low end that's been made very well. But often in these discussions, I just have the feeling that we all think we understand impacts. We know how serious they're going to be. All the impacts, every region, we've got that. And so now we just focus on the low end. And I just want to make a plea that that is not the case, and that if we don't plan to keep developing and using these higher end scenarios, we're going to find ourselves short scientifically in the future. Now, I think probably for now we have stuff we can use, right? If it's not 8.5, we have FSP7 and so on, and so this may not be an immediate issue, but something to keep in mind for the longer term. The other is that we haven't talked about emulators for impacts yet, right? So emulating climate Earth system model outcomes that we use as inputs to impacts. We've talked about emulators only for simple climate models for sort of working group 3 use. So that's, I won't say anything about that here, but I know there's emulator session or 2, and that's going to be really important, I think, to understanding what kinds of unique ESM runs we need to do. So I just want to throw that out there. And last is there's been lots of interesting types of questions raised that I think are great. I do think we have to keep in mind, are these important to do with lots of ESMs in CMIP or with a few ESMs in a paper or two? That's one thing. But the other thing too is that they all also overlap with other MIPs, at least other MIPs that have existed so far. And I think it raises the question, and again, I don't have a solution to this, just want to throw the question out there to have in mind of what is it that we want to do kind of in the core of scenario MIP, and what is a related but LUMIP question, or C4 MIP, or AirChem MIP, or RC MIP, right? The reduced complexity models that may want to have a specifically designed ESM runs to calibrate those types of models. And so we might want to think, when we think about designing MIPs in the future, maybe not so many runs in scenario MIP, but ones where lots of variants are run in other MIPs to address these more specific questions. We did some of that already in CMIP6, but we could probably do even more of it next time around.
Yeah, thanks for that, Brian. I was actually planning to say at some point something similar. So we obviously, with the design of the CMIP scenarios, we had this workshop in Aspen, which I thought was really useful, where we made sure that the scenario MIP scenario design, the LUMIP scenario design, and the AirCap MIP scenario design were somewhat calibrated, and so that we had in scenario MIP mostly these scenarios that would go from high forcing to low forcing. And then we had specific question on what does land use play a role, and we put that into LUMIP and made sure that the LUMIP scenarios actually were directly related as variants of the scenario MIP scenarios. And the same with AirChem MIP, where we deliberately designed scenarios around those that were in scenario MIP. And I think that for CMIP7 it makes sense to do that again, but maybe even with a much wider set of MIPs into that space. In reality, many more MIPs in the end used information from scenario MIP. And so with that proposal on CDR, I fully agree that this is a very interesting thing to explore. One way would be to add it into scenario MIP. The alternative is to make sure that with CDR MIP, we calibrate the research question and see whether we have one core scenario in scenario MIP and then the alternative variants in CDR MIP, and so that you actually have a full set. And I'm not sure what is the best way to do this, but I think having a design workshop at some point with several of these MIPs together and think a little bit of how can we make an encompassing research agenda and make sure that the MIPs speak to each other, I think is a very important thing to do. Somebody else would like to respond to Brian's questions? Otherwise, we go to further in the room.
Thank you. Microphone to work. Wonderful. Thank you. I have a question on how, in fact, different perspectives from different realities on the globe could or are already entering the scenario and the coupled modeling comparison project process. And so I'm very new to the community, but I would be curious on already existing ideas, or I would like to trigger more ideas concerning how does, for example, questions in the Global South could enter decisions on which questions are interesting in the policy direction, but also in maybe scientific, more scientific questions. So basically, how do we assure that very much people sitting around from the global north here, ensure a large perspective?
It's clear. So Jean-François, is that maybe also a question that is best addressed by you? So how can we make sure that CMIP7 answers questions of the policy and research questions from all over the world? Is there a process for that? Jean-François is one of the people online. Okay.
Hello?
Yes, great.
All right. So that's an excellent point. And again, I'm sorry, I don't know who you are, but it's an excellent point. So it will, one of the items that I will want to have, maybe as part of the discussion, the overall discussion that we're seeing on, well, so I think what I would like to see is that part of the definition of scenarios, but just in general of the MIPS and what kind of science questions we're tackling, is the implication of the impact community on whether this is going to be useful for them. And so I know this is a huge community, and we'll not be able to answer everything. And I agree that that's not the role of CMIP. Otherwise, we'll end up with CMIP6 on steroids, which no one wants. But I think the issues that you're raising about the global south and its implication in the definition of some of the studies that might be most relevant to them should be a key part in my mind of that optimization that I was talking about. So we should, by design, define some of those experiments such that they would specifically address the questions that you, and being general, you, not just you in particular, are most interested in. So we're going to try to reach out to the people through the process that I mentioned of those task teams, and then try to come up with those answers. But it will be important for you to provide us the feedback on this is the question that we feel we need to know to move forward in our understanding of how climate change and different options would be useful. So I don't have an answer, except that I will really try, and maybe the kind of things that Liv was also talking about, of bringing broader community into the definition of what the scenarios should be. But again, I'm not sure a scenario is a question that is the best tool for you to answer the question that you're most interested in. So I will try to provide a platform for people to give us this information, and then come up with the best way to address them.
Thanks, Sam. So
thank you.
We might need to close just only a little over 6, because the plenary starts at 6:15. So what I propose is that we take up all the last questions and then see whether there are brief answers by people here. So there's a question. There's one in the back.
Yes, thank you. So my name is Stefan Fonzek. I work at the Finnish Environment Institute, and I just want to come back to Brian's first comment on the kind of impacts of climate change, and not forgetting about kind of mid to high-end scenarios also. And I'm a regional climate impact modeler and adaptation modeler, and I just want to remind that there's a whole very diverse community, and just want to plea that you are also hearing that community, which are users of the CMIP output. So it's important to incorporate it also. And very concrete question too, since there are many of the scenario responsible people in the room here. Yesterday in the plenary there were 2 comments about potentially misinterpreting the labeling used in this scenario MIP, and whether you would want to comment on that. I think one comment was on the I understood not incomparability of RCP forcing levels with the labels used in scenario MIP, and the other one was the matrix structure, and that the IAV community want to just use the climate projections and combine that with any SSPs, and using the SSP label upfront is basically cause confusion, at least.
Yeah, thanks. The other question in the back.
Thanks. Hi, my name is Thierry from the University of Brussels, and I'm a climate and an impact modeler. My question relates to the timeline of CMIP7. So we have seen that in IPCC Working Group 2, basically most of the studies are based on CMIP5, right? Because CMIP simulations are being produced as we speak, and same holds for Cortex, where the runs are basically just starting now. So my question would be, is there a possibility to, in the design of CMIP7, to take this timeline into account such that the downstream impact and dynamical downscale modeling communities can have some time to do their runs and write their papers in time for the other working groups? And so, what could be concrete strategies there? Either increasing the time between the different IPCC reports, or bring the reports in, bringing the CMIP7 runs in earlier, or what could be solutions there? Thank you.
I'm going to add my quick question, which is, are we burying concentration-driven experiments forever, or do we see still a use for those? I mean, scenario MIP was concentration-driven and nothing else. Maybe we keep those for the high scenarios, better behaved and gradually increasing, or we do away with it?
Yeah, thanks. So these are the last three questions. Maybe do a quick round of responses. The one on the timing is probably Jean-François. It's the one that you have to answer. So are you still there? Can you come back?
Yes. So I don't have a timeline for CMIP7. The reason is I really want to make sure that we do it in a very well organized fashion, that we take into account lessons learned from issues that we had in the past. Some of them were discussed earlier by Matthew on issues with forcings and everything. My current plan is to really define a core of CMIP. So it would be, so there's the deck that everyone, at least on the climate modeling side, needs to do. And then what are the main items that we absolutely would want to see done in time for IPCC? Right, and then when I say IPCC, it's all working groups. So I think this was Wim, right, when Jerry discussing. So I think your point is very well taken, and I'd love to have a better understanding of the downstream downscaling steps that you're discussing. What are the times? How much does that take into it? Does that take, so that we can take into account that in our definition of what it would be. My reading is that a lot of efforts have to be put on having historical simulations, probably some set of scenarios, and then maybe some detection and attribution, and that could maybe be the core of what CMIP would be, and that would be the one with the really tied to working group 1 or schedule, and then the downstream portion that you're discussing. Probably not like what we tried to do this time with CMIP6, where everything was lumped into this huge monolithical approach that drove everyone crazy.
Okay, thanks.
So I think that's what we're trying here. The definition of exactly what the core is what we're going to be working on over the next year or so.
Yeah, maybe a quick response on the naming of the scenarios in scenario MIP. And so we wanted to communicate that in principle you could use these scenarios across the different columns, and so we didn't realize that the naming of the scenario by itself was confusing. We deliberately chose names that were different from the RCPs. That was important, and so we felt that this SSP3 RCP something naming was doing that, and I think we never realized that it was emphasizing that you are really in this cell and you can only use it in this cell. So this is a lesson learned, and that we should use a different naming next time if we would use that same matrix again. Somebody wants to respond on the concentration versus emission-driven scenarios?
I don't think concentration-driven scenarios can go away. I mean, there's a set of models which are not going to be able to do emissions-driven scenarios on. In running concentration overshoots. Not necessarily. I mean, this is a longer discussion. We can't avoid doing some concentration-driven experiments. There's a strong argument that we don't need as many as we had in CMIP6 because then we're not really learning very much from them.
So, yeah. I think it was a wonderful session. I think we discussed a lot of very important things. One thing that was striking to me is that when we started CMIP6, there was a lot of pushback also by the different teams in not having too many scenarios in scenario MIP and also making them really, really different. Because if there would be less than 1 watts per square meter different, they would not be recognizable. If there would only be about small land use differences, there would not be land use differences, they would not be recognizable. And so I think with some of the experiments we're currently designing, we would be taking on these very policy relevant questions, but again, we might get feedback from some of the teams that make sure that they're also different enough. Actually, for the overshoot, at that time the discussion was the same. And so in CMIP5 we had this huge overshoot scenario that was after based on the RCP 8.5. Then we went down because we wanted to make it more policy relevant. We were actually considering an even lower one, and then the feedback was now make it large enough so that you can see interesting physics happening. And so now we might redesign it for policy reasons, but I think that discussion on that make it different enough that you can see interesting Earth system dynamics, and at the same time making it policy relevant is a discussion that is important to have. Yeah, I enjoyed this session a lot. I think a lot of still needs to be done after this, with people thinking of how to best design these, and this was a good input into it. And I think at 6:15 we have the plenary.
We need to go. Thank you. You can comment still under our sessions if you have something that you want to say. And I wanted to thank the people online for their contribution, and Ben and Matt for theirs. And see you around.